Good day to all. Welcome to our instructional lecture in biostatistics. Okay, so for this topic, we'll be discussing an overview of parametric and the different types of parametric and non-parametric tests. So when we say parametric tests, they are the statistical tests that is used to analyze um, ratio and interval data, and this examines the relationship among variables and the differences between groups. So, in your parametric test, the focus or the parametric test can be used if your data that you are analyzing are classified as a ratio or an interval. So, if you still remember our first discussion before, we have the different levels of measurement. So, we have our different data can be classified as nominal, ordinal, ratio, or an interval scale. So if you're going to test the relationship, like for example, the height and the weight of our patients, no, the BMI and their um, blood pressure of our patients, then most probably we will be using a parametric test because those data are classified as ratio or an interval data. So in parametric test, we have these assumptions. So in order before we are going to use different types of parametric tests, we need first to ensure that we met the following assumptions. So the first assumption is that in terms of its distribution, the distribution of scores in a sample are expected to be normal, approximately normal, or a normal distribution or a bell-shaped curve. So in my previous discussion, when say bell-shaped curve or normal distribution, this means that the data is distributed normally. So iisa lang ang mean, median, and mode. So iisa ang mean, iisa ang median, and isa ang modes. For example, the mean, the median, and the mode equally divides the sets of value or sets of score into two equal parts. So that's what we mean by a normal distribution. So walang deviant samples or deviant scores or extreme samples in those given set of values or data. So how about number two, the level of measurement available or measurement of variable rather is usually at least interval or ratio. Then we are going to use a parametric test. And the lastly, the data or samples are obtained in simple random or random samples. So in short, our assumptions are the following. First, there should be randomization. Number two, the level of measurement are interval and ratio scale. And lastly, in terms of distribution, they should be normally distributed or approximately normal distribution. So if we have met those three parameters or three assumptions, then we can now use parametric tests. How about your non-parametric test? So non-parametric test is also termed as your distribution-free methods. So these type of statistical tests are used to analyze nominal or ordinal data. Like for example, the age, the sex, the civil status, and the faculty rank. No, um, if you're going to correlate or going to test the relationship between the age and the salary of a given set of sample or population, then we are going to use a non-parametric test. So in your non-parametric test, meron ding mga assumptions yan. So take note that the measurement should be at least nominal or ordinal. Then we are going to use a non-parametric test. Another, if they are of their or if they are not normally distributed, which means merong deviant samples, merong extreme scores, no? And the mean, median, and mode does not equally divides the sets of number into two equal parts, then we are going to use a non-parametric test. And lastly, kapag walang randomization, if there's no randomization, then we are going to use a non-parametric test. Or if the three assumptions in your parametric test wasn't able to have not met, no, then we will use a non-parametric test. So the advantages of a non-parametric test is it does not have restrictive assumptions unlike in your parametric tests. Another, easy and speedy computations and suited also for experiments and other survey studies. However, the disadvantage are the following. Number one, less efficient as compared to a parametric statistic because it only requires this only requires small sample size. You say large size is needed to reject a false hypothesis, and hypotheses tested with parametric methods are less specific compared to non-parametric. Okay, so this is the different parametric tests and its corresponding equivalent. So we have here the variables, the parametric and the non-parametric tests. So if you only have one variable or one sample, then we have a one sample t-test for parametric and a one sample sign test for non-parametric. For two independent samples, we have two sample independent t-tests, and we also have Wilcoxon rank sum test and the Mann-Whitney u-test for the non-parametric test. For two dependent samples, we have two paired t-tests for parametric and the Wilcoxon rank and the sign test for the non-parametric. For correlation, which is a very usual study conducted in the field of social sciences that includes midwifery, we have Pearson R for parametric and the Spearman rank order correlation for the non-parametric. Okay, in your Pearson R, marami yan. You have the Pearson product moment and the rest. For multiple groups or one factor, we have one-way ANOVA for parametric and the Kruskal-Wallis one-way ANOVA for the non-parametric. Correlation of variables or the test of association between variables in one group, which means there is no comparison. So if you're going to test the relationship of variables of one group or single group, then and there's no comparison, these are the different tests that we are going to use, and that would depend again on their type of measurement. Okay, like for example, we want to test the association between the shift work or the shifting of a midwife and their marital status in a certain hospital. So the variable here, we have the shift and the marital status. The shift could be classified as morning, afternoon, or PM or night shift, and those are what? That is a nominal data. Your marital status is also a nominal data. So which means if you're going to test the association between two categorical variables, the test that we are going to use is a chi-square. So chi-square, the symbol of chi-square is x and square, superscript 2, and that's your chi-square, not chi-square, but chi-square. How about if you want to test the association between the heart rate and the pain scale of hospitalized children? So heart rate is measured in terms of beats per minute, and the pain scale is classified into three, measured as mild, moderate, and severe pain. So take note, these data are classified as ordinal and an interval. Okay, ordinal and ordinal. Okay, so if you're going to test the association of this variable, the most appropriate statistic is your Spearman's correlation. And lastly, if you're going to test the relationship or association between the heart rate and blood pressure among students during the conduct of online exam, since heart rate and blood pressure can be classified as a interval or a ratio scale. Ratio, in terms of its level of measurement, could be an interval or ratio. Then the most appropriate test is your Pearson's correlation. Okay, ulitin natin. If you want to test the association between two categorical variables or nominal or an ordinal variable, that's chi-square. Like for example, the age, and the place of residence. Okay. Next, or the age and their income, or their age and their educational status. So we are going to use a chi-square. It's categorical. Those are categorical variable. If you want to determine the relationship between the heart rate and the pain scale of your sample, since they are ordinal and interval ratio, then we are going to use a Spearman's correlation. But if the two data that you want to correlate are both interval or ratio, the most appropriate test is your Pearson's R, or Pearson's correlation. Okay, so let's start first with your correlation and the linear regression. So linear regression, or linear correlation, and linear regression are the two most common methods used to describe the relationship between quantitative variables. If you want, what's the relationship between X and Y? What's the relationship between heart rate and the pain scale? What's the relationship between the anxiety score, anxiety level of students, and their performance or their scores? So under this, we have your linear correlation, linear regression, and your correlation coefficient. When we say linear correlation, this measures the strength of bivariate association. When we say bivariate, we have here two variables. What's the relationship between value of X and the value of Y? How about your linear regression? Your linear regression is a prediction equation, and it estimates the value of Y for any X. Okay, so which means that, like for example, the academic performance of students or their score and their anxiety level. So meron bang relationship ang um, kanilang anxiety level sa score during an exam? Look or determine the prediction between anxiety score or anxiety level and their performance during an exam. We also have your correlation coefficient. So this is a measure of strength between two variables provided that the relationship is linear. So to understand further, let's look independent and your dependent variable. When say independent, those are your presumed cause or cause. It is the treatment or an intervention. So when say you say independent, this means it can stand alone. So there is no, so this is the cause because particular cause can stand alone. Okay, how about your dependent variable? Kapag merong cause, meron din tayong tinatawag na effect. Okay? Kapag merong treatment, meron tayong tinatawag na outcome or result. Okay? So like for example, a midwife want to test the effectiveness of antenatal education to the birth preparation of the first-time mothers. So if this is your study, you want to test kapag effective na ba ang antenatal class or mother's class to the birth level of birth preparation of first-time mothers. So the effectiveness or antenatal education is the treatment. No, this could be a experimental study. This is the treatment. This is the presumed cause, and the effect would be the birth preparation of first-time mother. And the treatment is your independent variable, and your birth preparation or the birth outcome, the level of birth preparation is the dependent variable because we presume that antenatal education affects the birth preparation. Next, we also have the level of stress and the weight gain of students. So if you want to study the relationship between the level of stress and the weight gain of students, then let's look into the data into this sample. Their level of stress is the independent variable. It's the presumed cause, and the presumed effect of stress is gaining weight. Number three, the effectiveness of counseling and health teaching in smoking cessation. So with this one, we have two independent variable, and the two independent variable here is your counseling and health teaching. And the dependent variable here is the smoking cessation. So effective nga ba ang counseling and health teaching sa pag-reduce ng sa pag pag-stop ng isang smoker. And lastly is the student and faculty engagement and learner satisfaction in the distance education. So the independent variable here is your student and faculty engagement. And the dependent variable, the presumed cause, or the presumed effect or the presumed outcome or result of a good student and faculty engagement is the learner's satisfaction. Okay, so that's what we mean by independent and your dependent variable. Your independent variable are your presumed cause or the cause or the treatment or the intervention, and your dependent variables, the presumed effect, outcome, or the result. Okay. So to use linear or correlation regression, that would depend on the question or your research question, and of course, to the assumption of the data. So if you want to look into the relationship between the IQ, intelligent quotient, and the grade point average of a student, or this could be translated into a research question such as, is there a relationship between the concentration or, sorry, iba pala to. Okay, so if there a relationship between an IQ, the IQ level of student, and the grade average point. So in with this data, or with this question rather, we presume, or we want to determine if IQ affects the grade average or IQ affects the average of student. So with this question, there's a link we could determine, or we could appreciate here that there is a linear relationship between the IQ and the average. Okay, so if this will be your research question, then that's a linear correlation. Number two is the relationship between concentration of fluoride in drinking water and the number of cavities in children. So with this one, we presume we want rather to determine if there is really a direct relationship between the concentration of fluoride in the drinking water and the number of cavities in children. No, we could appreciate here that is we are looking into a direct relationship between two variables, fluoride concentration of fluoride in drinking water and the number of cavities, and that is a linear correlation. Another example. What change can occur if one's BP What change can occur if one's blood pressure after the reduction of salt intake? So with this one, we there are possible results. No? If you reduce your salt intake, um, what are the possible results in your BP? Okay, so in this question, we are looking into the degree of relationship between two variables. Okay, so what might be the result, or the BP is the value of y, which is the dependent variable, and the salt intake is the independent variable. So with this one, since we are looking into a direct cause or causation, then that's your regression method or regression analysis. In correlation, we have here your scatter diagram. In determining the relationship between two values, the values of x and y, we could use a statistical formula or statistical test. We could also use this scatter diagram or a plot diagram. So this is termed as your scatter diagram or scattergram. So this diagram plots the values of each pair of bivariate observation. So when say bivariate, dalawang variable, we have the values for the variable x and the variable y. Okay, at any point of intersection on the vertical line through the x value on the abscissa rather, and the horizontal line through the y value on the ordinate. Okay, so we have here okay, so we have here the y-axis, and we also have here the x-axis. The y-axis is the vertical line, and the x-axis is the horizontal line. So With this given set of example, no, we have here an example. We have the outpatient satisfaction Likert score. So 0 means satisfied and 5 means very satisfied versus the time with doctor in outpatient clinic consultation. So this study tries to determine the relationship between the time with the doctor in outpatient clinic consultation and the satisfaction of patients in the OPD. Okay, so in this graph, we have different plots, no? So like for example, patient 1, ang kanyang time with the physician is around, let's just assume na this is 4 minutes siyang kinausap or nag-consult sa physician, and then their outpatient satisfaction rate is below 1. How about participant number 2, 4, and their outpatient score satisfaction rate is around more than 1. Patient number 3, their time in the outpatient department is less than 5. Let's just assume this is 4, and their outpatient satisfaction score is less than 2. So, ang ginagawa natin dito, we are plotting the scores that would intersect the time in terms of minutes and their outpatient satisfaction rate. Okay? So, the independent variable here is we presume that the time with the doctor in the outpatient clinic consultation would affect their satisfaction, their outpatient satisfaction. Okay, so outpatient satisfaction is the presumed effect. It is the dependent variable. So with this type of data, napapansin natin na pataas, merong parang flow. If you could appreciate, merong parang direct line na pataas yan. So kapag pataas yung score, which means that the longer the time in their outpatient clinic consultation with the physician, the higher the satisfaction rate. Kasi pataas. Tama? Pataas, which means the higher or the longer their outpatient clinic consultation, the higher their satisfaction rate. So, kapag scattergram ang ginagawa natin, we could classify them as a moderate positive correlation. By the way, kapag pataas yung score, no, going up, that's a positive correlation kasi the longer the consultation time, the higher the outpatient satisfaction rating. Kaya positive correlation. Okay? So this term as a moderate kasi merong line pero medyo magkakalayo yung mga plot. That's your moderate. Strong positive kapag medyo magkakalapit yung mga plot. Perfect positive kapag diretso, no? Diretso yung kanilang plot, no? Kapag pababa naman, that's your negative correlation, no? Pababa, which means balikan natin, like for example, pababa ito, the higher the outpatient higher the outpatient satisfaction rating, the lower their time in their outpatient clinic consultation. So kapag pabaliktad yan, we term that as a your negative correlation. Kapag ganito naman yung result ng inyong scattergram, that's your no correlation kasi there's no pattern that could be appreciated in the plots. But if your correlation appears to a U shape or a bow shape, whether para open, concave, or convex, then there's nonlinear correlation. So what is correlation? So the correlation coefficient or correlation coefficient is often referred as your Pearson's product moment or the Pearson's product moment R. So this is introduced by Carl Pearson as a method of quantifying the relationship between variables, and these variables are either interval or ratio scale. So variable sila because dalawa, we have the variable x and your variable y. So the correlation coefficient indicates two things. Number one, it indicates the direction of the relationship, whether positive or a negative relation direction, or increasing or decreasing relation, and the degree of relationship, whether it's a positive or negative. So the value of correlation coefficient ranges from -1 to +1. So kapag negative, that's your negative or inverse relationship. Kapag positive naman, it's a positive relationship or a non-inverse relationship. So this is what I mean by positive correlation, pataas, negative correlation naman pababa, and kapag scattered, there's no correlation. The relationship or the direction of relationship. So if the correlation coefficient is positive, so the relationship is said to be direct. Okay, there's a direct positive relationship. So this means that a high value in one variable corresponds to a high value in the another variable. So for example, in the first scattergram that I presented, the it's a positive correlation because the longer the duration in terms of their clinic consultation with their physician, the higher the satisfaction in the outpatient. They're higher the higher their outpatient satisfaction. Another, if we believe that their scores of students in microbiology, the higher their scores in microbiology can also be would tend or students who are good rather in microbiology tend to perform high or tend to perform good also in biostatistics, and that's what I mean by positive direct relationship. How about if pabaliktad naman or iba naman yung kanilang relationship? So if the relationship coefficient is negative, the relationship is said to be inverse. So this means that one value is high and the other value is low. So pataas yung isa, pababa naman yung isa. So let's consider this example. Students who are good in biological science tend to perform low in biostatistics. Positive or mataas yung kanilang score sa biological science, whereas pababa yung kanilang score in biostatistics, and this is a inverse or negative inverse relationship. If there's no relationship or the correlation is zero, so this means that there is no relationship between the two values or between value of x and y. In terms of the degree of relationship, let's consider this table. So kapag positive, -1, positive means a positive relationship or a direct relationship. Kapag negative naman means an inverse relationship. So if the value of R is 1, it's a perfect correlation. If it's 0.81 to 0.99, high to very high, 0.61 to 0.80, marked substantial correlation, 0.41 to 0.60, moderate correlation, 0.21 to 0.40, definite but small correlation, 0.01 and 0.20, almost negligible to slight correlation, and 0.000, which means there is no correlation. So in the data printout in your SPSS, you're able to easily determine kapag merong mang relationship ng dalawang variables na yun because of the presence of an asterisk beside the given or beside the computed value. So this is the formula in your Pearson product moment of correlation coefficient. So um, alam ko nalulula na kayo and this might be a deadly formula. However, I have already will try to simplify this formula because this will be used. You're going to apply this in your future research studies. So let's assume that we have this given set of data, the scores or the grades in biostatistics and microbiology. So we want to determine if there is a relationship between the grades the grades of students in biostatistics class and microbiology. We have 10 samples or 10 students. Using the formula, let's first use a table, and then we compute for the value of xy, x square, and the y square. We get the summation of x. X stands for score in biostatistics. Summation of y. Y is your score or grade in microbiology. Summation of xy, summation of x square, and the summation of y square. So if you're going to get a total number or the sum of this column, the column of x, the summation of x would be 683. If you're going to get the total score, summation of y is 731. If you're going to multiply 78 times 85, x and y 630, 45 and 48, 216, 55 and 65, 300, 3,000, sorry, 6,630, 2,160, and 3,575. So that is your value of x and y or xy. So just multiply the values of xy to get the answers in this fourth column. How about the fifth column? In the fifth column, we are going to square the value of x. So 78 square. Using your calculator, you could easily compute for the x square. So 6,630. 45 square is 1,000. Okay. So for the 40 squaring 45 is 2,000. I guess I have some errors here. So we'll just try to check. So it's around 2,160 and the rest would continue. Okay. So what I want to emphasize here is to just um, get the square of the values of x. How about for the value of y? For the value of y, just continue squaring the scores in the values of y. For example, 85 square, 7,225, 48 square, 2,304, 65 square, 4,225. Okay. So after getting all their square, you just get the summation of y square, and we have 54,611 summation of x square, 48,528 summation of xy, 52,250. Since kompleto na yung mga values natin, just substitute the computed value using the formula, and the value of our xy, or the Pearson product moment correlation of coefficient, is 0.81. So this is a whole number, no? It's a whole positive number. So kapag positive, it's a direct relationship and not an inverse relationship. And considering the score is 0.89, mataas yan. So let's go back with the table presented. So 0.89 is around very high to very high. So the degree of relationship is high to very high. So this means that we could interpret the scores as the results indicates that there is a high positive or direct relationship between the performance in biostatistics and performance in microbiology. So this implies the students who excel or who are good in biostatistics tend also to perform good in microbiology. Okay, so you could watch this short instructional video to use on how to use your scientific calculator. And I will also be uploading a separate instructional lecture on how to use your scientific calculator in computing the Pearson product moment of correlation coefficient. Okay, so you also have your linear regression. Your linear regression is a prediction, okay? It's a regression equation or a prediction which is used to predict the value of independent variable on dependent variable. So Francis Galton coined the term regression during his study in heredity. So he's the one who coined the term regression. So he was able to identify the possible cause or possible effect of the values of x to the value of y, or to the heredity. So regression line describes the linear relationship between two variables. So this indicates the prediction of value of dependent, which is the outcome variable, and the variable y from a known value of a independent variable x, as well as expected change in the dependent variable for a unit change in an independent variable. So the formula in your regression analysis or linear regression is y hat. So this is symbol of hat, HAT. Yung may parang arrow na pataas. So y hat is equal to a plus bx. So y is the predicted value. X is the independent variable. A is the y-intercept, and D is the slope regression. So we have here the formula for your slope regression and the formula of A. Let's consider this example. We have 10 program supervisors, and we want to assess rather the relationship between their administrative capability and their productivity in implementing health programs under the Department of Health. So we're going to determine the relationship between their administrative capability and their productivity level, or their level of performance. So we have 10 program managers for Department of Health. These are their administrative capability scores, and these are their productivity scores. So if you're going to get the summation or the mean of their administrative capability, the mean score of the value of x is 4. Summation of ex, 4 times 10 is 40, no? Or if you're going to add, no? The values is summation of x is 4, and the summation of x squared is 166. How about your productivity? The mean is 4.1. Summation of y is 41, and the summation of y squared is 173. X and y. So x, y, rather, you just multiply the values of x to the value of y. 4 times 4, 16. 4 times 3, 12. 3 times 3, 9. And so on and so forth. Summation of xy is 165. Since we have already the given set of values, you just substitute the needed value in this given formula. Okay, I have also created a other instructional lecture or separate instructional video for this, for computing your linear regression. So substituting the given formula, ang nakuha natin, y hat is equal to a plus bx, y is equal to 3.34. That's the value of a. And b, or the slope, is 0.17. So this means that productivity level, or the productivity score of 3.41 plus 0.1 administrative capability. So what do we mean by this score? So this means that for every 1 unit change in the administrative level of administrative capability of administrators, their level of productivity increases by 0.17 units. So in a 1 unit change, no, pag tumaas ang kanilang kapag tataas ang kanilang productivity scores, ang kanilang administrative capability should also increase, or will also increase. Okay? So for your activity, determine the Pearson product moment R. Okay, so let's assume this is hypothetical case. So determine the relationship between the general weighted average of the different students and their score during their and the score in their Macboard rating or Macboard exam. So show your solution and provide a short interpretation. So this is the given set of data. Student 1 to 7, these are their general weighted average, value of x, Macboard rating, value of y. Find the summation of x, summation of y, the values of x, y, summation of x, y, the values of x squared, summation of x squared, y squared, summation of y squared, and determine the value or the Pearson RXY, or the Pearson product moment correlation coefficient. Okay, you could also use your scientific calculator as provided or as demonstrated in a separate video. Okay, and lastly, construct a scatter diagram using this given sample. Okay, so we have the value of x and the value of y. Okay, and then provide a short interpretation kapag linear positive relationship ba, or inverse or negative, or a negative or inverse relationship. So that's the end of our short instructional lecture in the first part of our parametric and non-parametric. We have the person product moment correlation coefficient and the linear regression. Okay, thank you very much for listening, and of course for your time. If you have any questions, feel free to send your queries or messages in our group chat. Thank you very much. Have a great day.